density calculations. In this section, we aren't really going to learn anything new. Just relate 4 things that we already know and point out to you that how they are related and that they can be used to solve problems. First, let's talk about density. The density of a substance is its mass divided by its volume. This is different than the molar density, which is moles divided by volume. We should note here that we can solve for molar density using the ideal gas law, because we know that PV equals nRT. And we know that the molar density is N over V. So, if we solve the ideal gas law for N over V, we get P over RT. This is a useful relationship to know, and more importantly, to know that you know it and that you can solve for this. And lastly, we'll talk about molar mass. We already know what molar mass is, and we know that it's mass over moles. However, I want to state it explicitly here to remind you that you are aware of this, that you know it, and that you can get it off the periodic table. Here, it's used to interconvert between these different concepts. Now, let's look at this again, but in a slightly different way. Here, I'm using the equations. In the next slide, I'm going to be talking about just their units. It's often useful to think of these in terms of their units, so that you don't have to memorize a bunch of equations to convert between them all. We'll do one example, but I just want to make sure that you recognize that there are so many ways to ask these problems. You'll never need to memorize all of the different problems. Instead, you'll be doing dimensional analysis. So when I'm talking you through the problem solving, pay attention to the units more so than the exact way that I'm doing this particular problem. Our molar mass is in grams per mole. So now you don't have to memorize any equation to relate molar mass. You just know if I ask for molar mass, you need to get grams, you need to get moles, and you need to put them over top of each other. For density, we have grams per liter. You'll often see density in grams per milliliter as well. But now you know if you find grams and you find liters, you can put them over top of each other. And finally, molar density. This means that if you can get moles in some way, or liters in some way, or in some way cancel out the units to get that you can find the molar density without having to worry about the equations. So let's look at an example. Phosgene is a highly toxic gas made up of carbon, oxygen, and chlorine. So I'm giving you the 3 things that it's made up of. I tell you that its density is 1.05 atmospheres at a particular set of conditions, 25 degrees Celsius. And I tell you its density, that it's 4.24 grams per liter. Now I ask you about the molar mass. I give you the density at a particular pressure and ask you for the molar mass, which means that we are trying to get grams per mole of a substance by using the pressure, the density in grams per liter. Also remember that we can solve the ideal gas law for P over RT. Now, if we solve the ideal gas law to get the molar density, we would have both our molar density, moles per liter, and our density, grams per liter. So we have grams and we have moles, and we have liters in both of those. So all we have to do is make sure that they cancel correctly, and we'll have our answer. So let's solve this first. We put our pressure on top, our R on the bottom, and our T on the bottom, converted into Kelvin. From here, we get our molar density. Now, recognize that if we put our grams per liter on top and our moles per liter on the bottom, our liters will cancel, and we'll be left with grams per mole. So let's do that. We'll put our 4.24 grams on top, our 0.4292 moles per liter on the bottom. The liters will cancel, and we'll be left with grams per mole. If you are going to do this purely by dimensional analysis, you may have to play around with it a little bit. Remember that this is just one example of many types that I could use. So do several of these in your book until you get the hang of using the units to do this properly. In review, we can use the molar mass and the density combined with the ideal gas law to calculate many unknowns. You do not need to memorize how to do these different types of problems. In fact, you shouldn't. There's infinite numbers of these problems that we could give you. Instead, focus on the dimensional analysis and converting between one and the other by looking at the units. Look at the process of how we decided what to do, as opposed to memorizing the equations.